values. So there are 4 blanks that they'll fill in. 0, -12, 0, 15. Okay, can you take some time to stare at these numbers? In the second row, all the y values. Do you notice anything? Huh? Where same? Really same? Which numbers are the same? Can you see similar numbers? Or rather exactly the same? Let's start from the outside. We've got 36 and 36. 15 and 15. 0 and 0. -9, -9, and -12. Does this remind you of anything? Okay, parabola. You should also realize that it is symmetrical. Both sides are the same. So this is actually a clue to tell us where our line of symmetry is going to be. Without plotting the graph, can you guess where the line of symmetry is? X equals to what? X equals to 0? Sounds like it. Because this is the only odd one out. This is the number in the center, where it has the lowest value of y, the minimum point. Everything else appears to be greater than -12. But we need to draw a graph to confirm. And they gave us more instructions. First, we need to have a range of x. X is from -4 to 4. 1 cm to 1 unit on the x-axis, 1 cm to 5 units on the y-axis. So good thing in our table of values, we start from -4 and we end at -4. Then we look, oh, the y values ranges from -12 to 36. So can you tell, is more of the graph above the x-axis or more of it below the x-axis? You have to visualize. The biggest number for y is 36. It's a big number. The smallest number for y is -12. So if I draw a graph, is there more graph here or more here? More on top, right? Then if we know that there is more on top, we need to cater more space to the top. Make sense, right? So when I zoom out, now we have to plan where we put our x and y axis. Okay, so I know more space on top. Maybe my x-axis should be somewhere here. Reasonable? There's more space on top. Now we need to confirm whether there really is enough space or not. 1 cm to 5 units on the y-axis. Every square over here, that is 1 cm. You can use your ruler to measure. So that will be 5 units. If this is 0, so 5, 10, 15, 20, 25, 30, 35. Is that enough? 35, then 40 here, right? So we know that the largest number of value of y is 36. So actually there is enough. But I would like to bring it just a little bit lower to give myself extra space, just a little. Okay, and at the bottom, if it's a case of 0 here, this is -5, -10, -15. Wow, I've got a lot of space at the bottom. Come, let's move it further down. Okay, so take a ruler. Can't remember where was my origin. Okay, so I'm going to shift it down by maybe one or two squares. So this is my x-axis. Okay, next, my y-axis, the vertical line. My x value ranges from -4 to 4, so I can safely draw my vertical line right in the center. There should be enough space. So make sure you have your labels, x and y. Please check. Okay, now we have to label. Every 1 cm represents 5 units. So we need to draw these dashes. And we have to draw the dashes at the bottom also. So block level 5, level 10, level 15, level 20, 25, level 30, level 35, level 40, level 45. So it's like an elevator going up, elevator going down. So you got level -5, -10, -15. On the horizontal x-axis, They want us to use 1 cm to represent 1 unit. 1 cm to 1 unit. So this must be 1, block 2, block 3, block 4. Should I continue with 5, 6, 7, 8? No need. They tell us it is until 4 only. So on the other side, -1, -2, -3, and -4. If you don't like all these empty extra space, you can take out eraser and erase all these extras. Okay, I don't need those at the side also. So this is the complete X and Y axis that is required. You have to ensure that you have the correct scale because that will give you 1 mark during your exams. Okay, now that we have this, we are ready to plot the points. Remember, the X and Y values, they have to go in a pair. So let us start with the first set of coordinates. Block -4, level 36. Block -4, level 36. So this is 35. Every 5 small squares represents 5 units. So one small square will be 1 unit, level 36. Be very careful where you plot it. Look very closely. This is not a difficult task, but it will give you marks. Okay, next one, block -3 and level 15. So block -3 is here. Level, what did they say? 15, level 15. Level 15 over here. So mark it out. Next, block -2, level 0. Mark it out. Block -1, level -9. Block -1 is here, level -9. Block 0, level -12. Block 0, level -12. So we see all the Y values are starting to drop, getting smaller and smaller until we go to -12. What happens after -12? Let's look at block 1. Block 1, level -9 again. Now you see a symmetry. Left hand side, right hand side, same. Continue to block 2, level 0, symmetrical. Block 3, level 15. Block 4, level 36. So having all these points will give you 1 or 2 marks. And we can visualize the shape. Just like our classmates tracing the giraffe, you know generally what it should look like. You look at this, you know it should be a curve this way, parabola opening upwards. Okay, so now please draw. We need to label. Oh, what's the name of this graph? Y equals to 3 times of x minus 2, x plus 2. That is the name of this graph. Use your graph to find the value of y. So finding the value of y means, what is the level? When x equals to 1.4. Oh, the block. It is block 1.4. What level does your friend stay in? So this curve actually describes where all your friends are staying. They don't stay just anywhere. So in block 1.4, the x value when it is 1.4, identify where 1.4 is. So this is the value of 1.4. You can draw a dotted line down. This is where my friend stays. I'll zoom in for you. Okay, I drew a vertical line down, this being 1.4, and he stays on this level. This is level -6. He stays at level of -6. And that is our y value. So answer for part 1, y equals to, they're asking for value of y, so y equals to -6. It's okay if your value is slightly different from mine. For example, if you got -5, -7, they will be accepted because we won't all have a perfect graph. Okay, as long as you're close to -6. Next, values of x when y equals to 2.5. Now it is reversed. This time, they want the block. Find the block when the level, that is y. Find the block when the level is 2.5. So take the leaf up. Take the leaf up to level 2.5. Somewhere here. 2.5 is in the middle of 0 and 5. So let's see who stays over here. Draw a dotted line across. Oh, there are two people staying here. The first guy stays at block -2.2. How did I get -2.2? Because this being -3, this being -2, 5 small squares represent 1 unit. So I've got one tiny square here. One small square will represent 1/5 units, which is 0.2. So one of my answers is -2.2. Part 2, x equals to -2.2. But there is another guy staying over here at level 2.5, and my value over here is, it's not too accurate, but I have here as 1.4. You probably will have actually 1.2. Hey, sorry. Wrong. Looking at the wrong thing. Here. This is the one. 2.2. Sorry, too many things, confused myself. Okay, so this is 2.2. Okay. So if you look at these two values, they are symmetrical again, which should make sense to you, since our parabola is symmetrical. So when just now I had 1.4, I started wondering, something wrong already. You should be able to catch those things also, knowing that they are symmetrical. Next, part 3. Find the equation of the line of symmetry of the graph. Before we can talk about the equation of the line of symmetry, can you identify where the line of symmetry is? So at the start of the lesson, I told you that in all syllabus, the line of symmetry for these graphs will always be a vertical line. It will always be a block. So here is my line of symmetry, a vertical line. This block, what exactly is this block called? Block 0, yes. In case you have difficulty identifying this as block 0, actually most people have no problem identifying block 1. Block 1 is here, right? Block 2 is here. Block 3 over here. So if you go backwards, block 3, block 2, block 1, this must be block 0. So the line of symmetry is block 0, and it passes through the minimum point. So blocks are also known as x. X equals to 0. Note, for part 3, do not leave answer as 0. 0 is a number. It is not an equation. Look, they want an equation. Equation must have equal sign. This 0 over here is a number. then you cannot just write equals 0. It must be something equal to 0. What is the something over here? X. Very good. So, part 3, x equals to 0. I hope this gives you more confidence to score for your graph questions. They always carry a lot of marks. More question over here. Use the shape to create a pattern design. I would say something like this. Right? This is probably one of the most basic shapes that we can get. Of course, there will be other accepted answers also, but I'm lazy to think of so many different answers. What about this? Draw a rectangle, okay. So you mean join another piece like this? Okay, so you flip it around, rotate it, just get another piece like this. So actually we can just continue lah. Slash here, vertical line. Slash, vertical line. And of course you can repeat it again over here. Slash, vertical line, slash, vertical line, slash. So this is my next design. Okay, regardless of what you do, I must see a pattern being formed. Something that repeats itself a few times. What do I mean? By showing me this, it is not good enough. I don't see any repetition. Okay, and if you were to do this, also not good enough. I don't see a repetition. Okay, but if you choose to show me a few more, like this, then maybe like this. Getting quite difficult. Okay, if you show me something like this, I can see a repetition. Then I will accept. Okay, we're going to skip question 8, question 9 in your workbook because they are just creating patterns. We're going to head on to question 10. You can see that we're going to be finishing our Sec 3 workbook really quickly already. Not many questions left already. Let's take some time to understand this question. In each of the following, 10 candies are to be put in a container such that there is no empty space. Find the value of x. So this is the candy. It looks like a mushroom. And quite clearly they are stacking them. They're putting them side by side. Oh, they're asking you for the value of x. When there are 10 candies, what do you think x is going to be? What do you think it's going to be? 20, right? 2 times 10. Not difficult also. X equals to 2 times 10. 20 cm. Okay, x value is 20. That's it. Now you can do this yourself. We are trying to prepare you to use mathematics in real life. So many of these problems, we try and link them to real life, something that we can experience. So that when you grow up, when you go out to work in society, so what do you have as an answer? 3 times 10. And we get 30. Done. Next page. Okay, so that was kind of like a warm-up question for you. Now we have biscuits. It is a cuboid. Cuboid are, they look like this. All 90 degrees at the edges. Sorry, at the corners. The dimensions just mean the length. We've got 6 cm, 5 cm, 2 cm. Then we have a container to contain 20 of such biscuits, such that there is no empty space. I've got a container, I'm going to put 20 of this inside, 20 pieces. And this box over here has dimension of 6 and 5, and x. Of course, they're going to ask you to find x. What do you think x is going to be? So part A, x will be, I know it's going to be 20 times something, but 20 times what? 20 times what? 2. How do you know it's 2? Why can't it be 6? Ah, yeah, okay. So you should realize that, hey, this 6 should be in line with this 6. This 5 over here should be aligned to this 5, such that each piece will look like this, 2 cm. There you go. Okay, so we have many of these pieces. Since there are 20 pieces, it is going to be 2 times 20, or rather 20 times 2, 2 times 20, same thing. So x has a value of 40. The units will be centimeters. Okay, I didn't draw this very well. It should be parallel. Okay, and the last piece probably looks like this. Now part B. Find the total surface area of the outside of the container. So this being the container, we found that x is actually 40 cm over here. For part B, total surface area, can you visualize what they actually want? If this is the cuboid, if this is the container, where we have 5 cm here, 6 cm, and 40 cm. The surface area outside the container, we've got one surface area on top, got another one below, 3, 4, 5, and 6. 6 of them. You can go and calculate every single one of them. 40 times 5 to get the top, times 2 to get the bottom, then 6 times 5 to get 30 times 2, then 40 times 6, then times 2. But it's troublesome. So many things to add up. So I've taught you that we can actually simplify our working by identifying where is the cross-sectional area. Because this is a cuboid, you have 3 options for a cross-sectional area. You can choose this as your cross-sectional area. So you find this area times 2 to get both of this. So there are 2 of them. Then you take the perimeter of your cross-sectional area looking like this. This is your perimeter. Once you have the perimeter, you multiply by the thickness. Add them up. You get a total surface area. That is one way to do it. Another way is if you choose your cross-sectional area to be, for example, here. If you choose the cross-sectional area to be at the bottom, you can do that. Then you multiply by 2 to get a cross-sectional areas for the top and the bottom. Then identify where your perimeter is. So this is your perimeter of a cross-sectional area. Multiply by this. Okay, so there's 2 options already. The third one, the cross-sectional area will be the front times 2. Then this will be our perimeter. Okay. Now, you try out of these 3 methods, out of these 3 different ways, which one do you prefer, and do it. Then we check our answers in about 1 minute. Okay, please start. Okay, I will shade this face to be my cross-sectional area. So there are 2 of them. There's one at the back also. Okay, so now, total area. Please write down these words, total area, so that you don't just give me a chunk of numbers multiplied by each other. Then I don't know what you're doing. Must write, oh, I'm trying to find the total area. Formula. 2 times of the cross-sectional area. One of this cross-sectional area is given by 6 times 5 cm, because it is the area of a rectangle, length times breadth. So 6 times 5. So now, I've got the 2 yellow shaded areas. I still need to add to the 4 other faces. The formula, or rather the way to find the area for the 4 other faces is like this. Outline the perimeter of your cross-sectional area. If your cross-sectional area is at the bottom, then you outline the cross-sectional area at the bottom. Since my cross-sectional area is this yellow one, I will outline this yellow cross-sectional area. Now, all we need to do is to find the perimeter of this. The perimeter of this rectangle. We know that since it is a rectangle, this must be 5 and this must also be 6. So perimeter is given by, open bracket, 6 plus 5 plus 6 plus 5. Close bracket. Now this is just the perimeter of cross-sectional area. We still need to multiply this by the thickness. The thickness is this length. This value we found earlier, it was 40. Okay, so this 40 over here is our thickness. Then I'll just highlight this 6 times 5 to show that this area is for the yellow shaded part. From here on, make sure you enter the values into your calculator accurately. So 6 times 5 plus 6 plus 5 plus 6 plus 5, close bracket, open bracket, 40. Answer 940 square centimeters. Now part C. Cost of making this container. If the material costs 50 cents per 0.02 square meters. Oh no, the units over here are square meters. My unit over here is square centimeters. I need to do a conversion. 940 square centimeters equals to how many square meters? So recap, if I'm trying to convert centimeter to meter, what do? Divide by how much? 100, yeah. From centimeter to meter, we divide by 100. But right now we're not changing from centimeter to meter. It's from square centimeter to square meter. So instead of dividing by 100, what should we divide by? 100 square. That's it. Use your calculator to help you. Divided by 100 square. And we get 0.094 square meters. So apparently